Hi, and welcome back to our Chemistry Flipped classroom. So today we're continuing our conversation about the mole. So we've already been introduced to the mole, and we know that it's a counting unit, just like a dozen is a counting unit, or even a ream. And we know that the mole has this very strange number attached to it as far as a counting unit, and that number is 6.022 times 10 to the 23rd. And we call that number Avogadro's number. And so we know that a mole of anything contains 6.022 times 10 to the 23rd things, whether those things are molecules, atoms, formula units, compounds, or even something like an M&M, or even larger. We know that it contains 6.022 times 10 to the 23rd things. And we know that that number is that number because that allows us to recognize that the mass of one mole is in grams the same as the mass of one atom of that same thing, or one formula unit of that same thing, or one molecule of that same thing in atomic mass units, because the definition of the mole comes from the definition of carbon-12. So there are exactly 12 grams of carbon-12 in one mole of carbon-12 because there are 6.022 times 10 to the 23rd atoms of carbon-12 in a mole of carbon-12. So this is where the mole starts to become useful and not just some random concept, because now we can measure mass, and we know that if we have the mass on the periodic table of an element in grams, that we have one mole of that element. And so we're going to continue working with the idea of molar mass today. And so molar mass is the mass of one mole of a pure substance. And we find molar mass, and we write it in terms of grams per mole, and we find that molar mass on the periodic table. So if we look at nitrogen on the periodic table, it tells us that it's 14.007 atomic mass units for one atom of nitrogen. That means that there are 14.007 grams of nitrogen in one mole of nitrogen. In the same way, if we look at lead and we look at the periodic table, we see a number of 207.2. And we can read that either as 207.2 grams per mole of lead, or 207.2 atomic mass units for one atom of lead. So this allows us, again, to take the nanoscopic, to take that tiny, tiny thing that is an atom and scale it up to where we can see it and we can measure it in a lab. So let's do a little bit of practicing with the molar mass. So I'm going to stop our share here for just a second. And we're gonna switch to the other camera. Oh, we gotta flip it around. Sorry about that. Okay, so here's our periodic table. This should seem very familiar to us. We've been using this all year long. So here's our periodic table, and we're just gonna practice finding molar masses. So if I ask you to find the molar mass of an element, all you have to do is find that element on the periodic table. So we're going to start by finding the molar mass of sodium. So we know that sodium is Na. So we come over here to Na. Let's see if we can't zoom in a little bit so you guys can see this a little better. Oh, evidently I can't zoom while we're here. So sodium, we can see, is 22.990. So if I asked you to find the molar mass of sodium, you would go to sodium on the periodic table, and you would say the molar mass of sodium is 22.990 grams per mole. Or you could just say that it's 22.990 grams. Because when I ask for molar mass, the understanding is that it is per mole. So let's look at carbon. So we're going to find carbon on the periodic table. So here's carbon right over here. And carbon has a mass of 12.011. And again, that's 12.011 grams per mole. So this is pretty simple and straightforward so far, and it's going to continue to be pretty simple and straightforward, but we are going to take it up one level. We're going to just look at one more before we go. So iron, we know, is in the metals, so it's in the middle of the periodic table as a transition metal, and its mass is 55.845 grams per mole. So again, these are molar masses, so they're in units of grams per mole. What if I ask you to find the mass of a diatomic element? So now, if we look at chlorine as one of our diatomic elements, and we see that outline of the 7 and the 1, and we remember that those are our diatomic elements. So if I ask you to find the molar mass of a diatomic element, you're going to look at the mass, and we find that the mass of chlorine is 35.453. But because there are 2 chlorines in this molecule, we're going to multiply that by 2. And we're going to have 70.906 grams per mole. And that's the molar mass of chlorine because chlorine is diatomic. So we'll do the same thing with oxygen. We look at oxygen on the periodic table, and we see that it has a mass of 15.999. But knowing that it is diatomic, since we're looking at a molecule of oxygen, we're going to multiply that by 2, and we're going to get 31.998 grams per mole. So again, whenever we have a diatomic element, if we're asked to find the mass of that diatomic element, we're just going to multiply the molar mass on the periodic table by 2. Okay, just a couple more examples. So if we're asked to find the molar mass of sodium chloride, now we're finding the molar mass of a compound. So we're going to add up the masses of the individual elements. So we find the mass of sodium, which is 22.990, and the mass of chlorine, which is 35.453. And we're just going to add those masses together. And we'll find that the mass of sodium chloride is 58.443 grams per mole. So again, we're just adding up the masses of the component elements. So last example, we're going to take a look at potassium carbonate. So when we look at potassium carbonate, we're going to add up the masses of all of the component elements. So we're going to look at the mass of potassium, and potassium is 39.098. But we have 2 of those, so we're going to multiply that by 2. Now we're going to add the mass of carbon, which is 12.011. Again, we're looking at the periodic table to find the mass of carbon. And the mass of oxygen, which is 15.999. But there are 3 oxygens, so we're going to multiply that by 3. So we have to, anytime we have a subscript, we need to multiply that mass by the subscript. And we want to add all of them up together. So when we find the mass of potassium carbonate, we would have 39.098 times 2 plus 12.011 plus 15.999 times 3. And that's going to give us a mass of 138.204 grams per mole. Okay, so that's how we find molar mass. As always, if you have any questions, please let me know. I look forward to seeing you guys in class.